Hey, 8th grade. So today we're going to start talking about the electromagnetic spectrum and how much energy do different waves carry. So first, let's start about talking about some characteristics of waves. There's a few different terms that you need to know when we look at waves. One is the amplitude, and that is the height of the wave. The frequency is the amount of waves per second. So you would need time in order to figure that out. And the wavelength is the distance from one point on a wave to the same point on the next wave. So for instance, if you go from peak to peak or crest to crest and trough to trough, the crest is the peak and the trough is the lowest point. And if you look down here, I put a picture of the electromagnetic spectrum. And one thing to notice is that the frequency increases as the wavelength decreases, or the distance from one point to the next. So what do electromagnetic waves do? They carry energy through space, and they don't actually need any type of medium to travel through. All waves travel at the same speed in a vacuum, which is considered an empty space, but they have different wavelengths and frequencies. Radiation in the wavelengths that your eyes can see is called visible light, and only a small portion of the spectrum is actually visible light, while the rest is invisible to human eyes. So when we look at electromagnetic waves, as wavelength decreases or that distance decreases, the frequency increases. Because there's less of a wavelength, there are more waves going through. The amount of energy carried by a wave increases with frequency. So as the frequency increases, the amount of energy increases. So the higher the frequency, the more energy it's carrying. The electromagnetic spectrum is the complete range of electromagnetic waves placed in order of increasing frequency, and is made of radio waves, microwaves, infrared waves, visible light, ultraviolet waves, X-rays, and gamma rays. So as you go from one end to the other, you notice that the frequency increases, and only this small portion right here is where you have that visible light. And this is just another picture showing you some things that might actually pertain to all the different wavelengths. So you have the radio, microwave, infrared, which is that heat sensing, visible, ultraviolet from the sun, X-rays, and then of course gamma rays, which can consider like a biohazard sometimes. So at one end, you have long wavelength, low energy, low frequency. At the other end, you have short wavelength, high energy, high frequency. So as these waves get closer and closer together, that wavelength shortens, you have more and more energy. The radiation behind all of these things is exactly the same. It just has different amounts of energy in it. So just another picture that shows you the visible spectrum, very small area, and all of the waves with increasing frequency and a shorter wavelength. Go ahead and move on to the rest of your work for today. And your exit ticket is on paper.